Alright, welcome back guys. We're going to go ahead and continue with our lesson. Okay. As far as vocabulary, there's nothing new beyond that extra credit sheet I gave you guys during the third 9 weeks exam. Okay. So you still want to explore that vocabulary, look at some examples, and kind of improve or at least master some of that vocab. Okay. Anyways, we're continuing with chapter 8, and we've got a couple examples to look at. So this one says to solve the equation. I think most of you guys have the foundation to approach this kind of problem. Okay, many of you guys would think to multiply by x to both sides to get rid of it here as a denominator. So let's go ahead and do that. Okay. Now I am multiplying it to the whole left side, not just this x. That's why you've got to use the parentheses. Okay. And this becomes just an old school problem. Okay. We're going to bring that other term this way by adding 18. All right. We're going to look at this problem and see if we can factor it out. Right, let's go. And if you're not super fast, again, the homework problems are there for this current lesson and previous lessons. It is in your best interest to work them out until you've improved your speed, okay? So you can kind of keep up, and that speed will carry over to pre-calculus. Alright, so this statement here says that this times this equals 0, so at least one of them must be 0, so we can kind of explore this. Now, although at this point you may not need to show your work, I still like to do so that you don't forget why we get what we get. Okay, and we get 6 and 3. Okay, through some very basic math. Alright, done and done. Okay, next we have to solve the equation as follows. So let's go ahead and get this one started. Now, as soon as I start this one, okay, I do want to observe that the denominator should not be 0, because I'd be dividing by 0 if that was the case. So I'm immediately going to exclude 3. Right? If I come back here, I probably should have done the same thing, so I'll do it now after the fact, and I'll say that x definitely should not equal 0 to avoid dividing by 0. Okay? And I'll add that here as an additional statement. X cannot equal 0. Okay? Very important. Now, the fact that my solutions don't involve 0 is not a problem, but you should always keep that in mind. Okay, it's very easy to kind of forget and get into trouble. Alright, so what we're going to do with this one is the same thing we did on this last one, which is get rid of the denominator. Okay, so minus 3 equals. Alright. So it's going to be canceled, and now we have, let's go ahead and subtract 4x from both sides. And at this point we can go ahead and divide both sides by 2, which leaves us x equals 3. Alright, so that's my solution. I'm done. But oh wait, we keep on coming into this situation where we need to determine what values of x lead these expressions to be undefined, and x was declared as not available. So I must include that here. X cannot equal 3. Once again, like we've seen before, these are contradictory statements, so I will describe that the solution set is the empty set. There are no solutions, okay? Or I can be explicit and say no solution. Alright? Okay, let's move on. You want to solve the following inequality by using a graph and a table. So let's go ahead and set this one up. Now, though there's algebraic methods, let's go ahead and follow instructions. So graphically, let's go and do that. Okay, I'm going to assume that this itself is a function and this one as well. Then I'll address the inequality portion. Okay, so x over x minus 6. Let's kind of start fresh here. Right, I always like to clear the calculator in case there's stuff saved. I don't need to run into needless trouble. So some of you guys like this feature, I do too. Is it this one? This one. Okay. So it's x over x minus 6. Okay. And the other function, let's go back to the problem, is simply -1. So I'll hit tab, or I guess enter. Okay. And now I'll hit tab, -1, enter. Okay. And this is what I have so far. Alright. The next thing that we're asked to do, let me go back. I'm going to capture an image. See if we can save that. I'm doing this so I have a quicker reference. I can kind of make some comments here for you guys about the problem. Okay. And so use a graph and a table. Let's go back to the calculator. And we're going to go Control T to access that table. There's other methods, but I think that's one of the quicker ones. Alright. Alright. Let's see here. Let's see here. So this table is not revealing everything, but I'll use what I can in it here initially. Alright, you must really understand what's being displayed here so you can use it. Okay, here's kind of the top chunk. Let me go back to the calculator. I'm going to go down some values. About there. Alright. Okay, so there's multiple screens, and that's the main reason why I'm pasting them on here. Alright, so now that I've got all my information in front of me, I'm going to use it to kind of address what I've been asked to address. Let's see here. Okay. Now, once again, I forgot, and I know you guys will forget, is to look at those x values that would make this undefined. So I'm going to immediately exclude 6. Okay. So they didn't prompt me, they're not asking me, but it's just a given, something that you got to be on the lookout for, okay? Now, I do this at this moment, which I should do anyways, but I'm doing it with the purpose of linking it to this x value of 6. Look what it says, okay? If you look at your own calculator, it says undefined, and now you know why. Okay, that's for that first function, which is this portion, and then the second function is just the -1, okay? All right. So what we're looking for is the solutions. So when is this value bigger or equal to -1? Okay. Let's go and see where that happens. So is this bigger than that? Yes. Okay. How about this one? Yes. How about this one? Yes. At 4? No. How about at 5? No. 6 is undefined, so no. And then at 7. Okay. Does 7 work? It does. And 8. 4 is definitely bigger than -1. So then, alright, what we want to establish is that, here we go, x what? Alright, we want to describe the solution, so let's go ahead and use SS for solution set. Okay, so the solution set we can say is all the x's, okay, and we can use set builder notation just as a part of a review. Okay, so the solution set is the set of all x's such that x is what? According to this, look at all these x's. They're either 3 or less than, right? So all the x's that are equal to or less than 3, comma, what's the other side of this? Okay. We're going to say that all these values here would work. Okay. Notice how 6 didn't work, so I'm going to say that x, all the numbers what, greater than 6. So it doesn't include 6, but everything bigger, so 7 and so on and so forth. Alright. And the next problem, once again, solve the inequality algebraically. So this time I'm going to get a jump and I'm going to immediately declare what value is not legal. Okay, would make this undefined, and it's x cannot equal -3. You can set it equal to 0 and solve it, we'd get the same answer. Okay. Alright. So with this kind of problem, alright, because it does say algebraically, here's the approach. We're gonna end up multiplying by the denominator, but because there is a variable down here, it could ultimately be positive or negative. Okay, so let's go ahead and describe two cases. Okay. Divide the page in half. So case 1, I'm going to call this guy the LCD, the least common denominator, okay, or divisor, is positive, right? And then case 2, least common divisor is negative. At some point this could be positive for certain x's, and it could also be negative. Okay. Alright. So whoops. So one thing you want to notice is that the sign changed. Okay, it's got the same effect as if you were dividing by a negative, right, or multiplying by negative. The sign would change. Okay. All right. So let's go ahead and take care of that multiplication of x plus 3 to both sides. So far, notice, okay, so you don't overcomplicate things. Everything's identical. The only thing that's changed is the plus and the minus. When it's plus, you keep the sign the same. When it's minus, you switch it. Okay. The math is identical. Okay. So we're left with 5, 6x plus 18, 5, 6x plus 18. All right. And here I would subtract the 18, so I got -13. Same thing here. Less than 6x, greater than 6x. Okay, and I would divide by 6, so there's that expression. And okay, I'm working them side by side so that in large part you can really see that this is simple, especially since you're just duplicating your efforts. Okay. Alright. Let me see what we have here. So we have case 1, case 2. The other thing I want to do is I'm going to call this step 1. And step 1. Okay, so each case has its step 1. And then comes in a step 2 for each one of these. Okay. In step 2, what you want to do is look at the denominator, and you've got this expression, right? Why? Because we've declared that the LCD is positive, so we know it's got to be bigger than 0. In this scenario, it's going to be negative, so we know that this expression must be what? Less than 0. Okay? So we do some quick math on that. Right? Subtract 3, we get x is greater than -3, and here we get x is less than -3. Okay. All right. So what we're going to do here now is we've got essentially 2 possible solutions. Okay, we're going to use them to describe the ultimate solution for the problem. Okay, so we're going to have, in this case, if x is greater than this quantity and x is greater than this quantity, if we were to combine both of those statements, okay, the one that would make hold true in both cases would be this one. Okay. Now let's look at this scenario. If you have x is less than this quantity and x is less than this quantity, okay, which one would hold true in both scenarios? And we would go with x is less than -3. Okay. So we can go ahead and put the word or in between to describe the solution set. Okay. Alright, so I'll admit that one had a lot going on. Okay, just kind of take a deep breath. This one is the last one, and this one's a lot more straightforward. Okay, so really out of the 5, 4 of them are pretty straightforward. That last one we looked at, we'll spend some time in class looking at it a little closer. Okay. Alright, so here we are, solve the equation. Now, because seeing the factors themselves isn't super obvious, it's going to take some work here, okay, to get them in factored form, so let's do that. Once again, that's why you want to have the practice so you can really, okay, 2 numbers that multiply to give you him, so let's go -9 and +2 equals 6x. Right. So even me that I've been doing this for a while, the skeleton just does an awesome job. So, alright, I'm going to go with +2. Okay, so these multiply to give me him, and they add to give me that one right there. Okay. Alright, so as I'm doing this, I'm getting better at excluding the values that would make this undefined. So I have -2, I have 9, I have -2 again, and I have 1. Okay, so those guys are out, and I got to remember that to write that down. Okay, check me and see if I do that. Alright, so the next thing that I want to do is, okay, I'm going to multiply by these denominators to each side. Okay, here's what I mean. So these denominators, I'm going to multiply them to both sides. Okay, check this out. I'm going to multiply by x plus 2. I'm going to multiply by x minus 9. And I'm going to multiply by this x minus 1. Okay, so check this out. See, let me go a little slower. I'm gonna multiply by these two so that they can cancel out here. Okay. Now this side I'm gonna multiply by x plus 2 and x minus 1 so they can cancel out. Now I must do the same thing to both sides to be fair. If you notice, this one has an x minus 1, this one doesn't, so I'll toss it in here. And he has an x minus 9, he doesn't, so I'll toss it in here, x minus 9. Right? So look at what's going to happen. A lot of nice cancellation. So these two are canceled out, and I'm left with 2x times x minus 1 equals, these two are canceled, so I'm left with 6x times x minus 9. Alright. This is proven to be one of the longer videos ever, but we've had a nice, 1, 2, 3 break. So 1, 2, 3 week break, so you guys will be alright, but we're almost done here. So now I'll carry out the multiplication. Now, in good faith, I'm going to continue to carry this information down here. Okay. X cannot equal -2, 9, and 1. Right? This is very pre-calculus-like, which is a very good habit moving forward. Alright, let's go ahead and get 2x squared minus 2x equals 6x squared minus 54x. Alright, I'll leave that out for a quick second. And now we can go ahead and take care of some quick math. Right. If I subtract the 2x squared, I'll get 4x squared. Right. If I go ahead and add 2x, I'll get minus 52x. And over here I'll be left with 0. Right. At this point, because I've moved the screen, I don't want to forget this information, so I'll carry it over. -291. Now, you guys have been here before. This is where you identify a GCF, and by my assessment, it looks like it's a 4x, so I'm left with x minus 13. And if it's something times something equals 0, either one of them should be 0, so I've got 4x equals 0, or x minus 13 equals 0. And after I divide by 4, I get x equals 0, and over here I get x equals 13. Right? So the solution set is x equals 0, x equals 0 and 13, semicolon, x cannot equal what? -2, 9, and 1. Alright guys, thanks for your time. I'll definitely keep the videos a lot shorter than this. Appreciate your time, and I'll see you guys in class.